Consider the following formula. Which of the following statements is true for this formula? To find the relationship between y and w, we should graph this function. And before we graph, let's label our axes. Normally, your x-axis is your cause variable. Something is happening to x to create the result or our effect, which is the y-axis. So if we look at our answer choices, we can see that w is the cause variable that is affecting y. When w is less than something, y is either positive or negative. So we can label our x-axis as w, and our y-axis can stay y. Now let's find our intercepts for this graph. So first we'll find our x-intercept, which is where y equals 0. So we can set y equals 5 minus 2w, set y equal to 0. So we'll have 0 equals 5 minus 2w, and now we'll solve for w. We can add 2w to both sides. Adding is the opposite of subtracting, so this will cancel, giving us 2w equals 5. And then we can divide both sides by 2, since 2 is being multiplied to w, and division is the opposite operation. Our 2's will cancel here on the left, giving us w equals 5 over 2, or the decimal form of that, which would be 2.5. Now let's find our y-intercept, or where x equals 0, or in this case, w. We have y equals 5 minus 2w, and we'll need to substitute 0 in for w. 2 times 0 will just give us 0, so we'll have y equals 5, because this will have completely canceled itself out. So our 2 points that we need to plot are 2.5, comma 0, that's our x-intercept, and then our y-intercept of 0, comma 5. Here I have plotted our two intercepts. We have our x-intercept over 2.5, up 0, and then we have our y-intercept, which is up 5 over 0. And now we can start to analyze the graph. For all of the values less than w equals 2.5, our x-intercept, all of these y values that we can see here are all positive. So we can make a statement that says when w is less than 2.5, y is positive. And then, again, making that point our point of focus here, everything to the right, or everything greater than this point 2.5, has y values that are below the x-axis, which makes them all negative. So we can write another statement that says w, when greater than 2.5, it will always have negative y values. So with that in mind, we can go through and look at all of our answer choices and see which one is correct and which one is not. A says if w is less than 10. So we'll say 10. We have 1, 2, 3, 4, 5, 6, 7, 8 on the graph. So we'll say 10 is out here somewhere. If w is less than 10 going this way, then y is positive. Well, it will become positive eventually once we pass over this point right here, w equals 2.5, then all of our y values will be positive. But until we get to that point, we are going to be slowly climbing up the negative values of this graph. Let me grab a different color. Slowly climbing up the negative values of this graph until we pass 2.5, then we will be in the positives. So answer choice A is incorrect. B says if w is greater than negative 2.5, which would be over here, negative 2.5, and greater than would be to the right, then y is negative. Again, this isn't true. If we were to follow this point up, it would maybe be right about here, and then everything greater than this point would have all positive y values until we cross this w equals 2.5 point, and then all of the y variables would be negative. So B is also incorrect. C says if w is greater than negative 2.5, y is positive. That's again partially correct, because it will be positive for a while until it crosses that 2.5, positive 2.5 point, and then it will become negative. So C is also incorrect, and by process of elimination we can see that D is our correct answer, but let me show you exactly why D is correct. D says if w is less than 2.5, y is positive. Well, 2.5 is exactly our x-intercept. And all of the values that are less than 2.5 or to the left of 2.5 are all infinitely positive. That was according to our statement here. So D is our correct answer.